All right, in this video here, we're going to do one more example of solving a trig equation, and this one is one of the more complicated ones that we'll take a look at. If you haven't seen the other videos that I've done of solving trig equations, I've done 6 or 7 or 8 of them. I've kind of lost count at this point. But I've done a bunch where I kind of started with really simple trig equations, and then kind of all along the way, they got more and more complicated. So if you haven't seen any of those other ones, you might want to not watch this one first. You might want to go back and watch some of those easier ones and then kind of work your way up to this, one of the more difficult ones that you're likely to see. Just my advice. But if you want to see this one, if this is what you're looking for, then by all means watch this. All right, so square root of 3 times tangent of theta over 2 minus 1 equals 0. All right, so first thing, I don't have tangent of theta. I have tangent of theta over 2. Right, which is not really going to change the first part of what I do in this problem. It's going to change when I get to my answers and my solutions. It's going to change how I do that. Right, so I'm going to proceed with this one just like I would with any other trig equation. First thing I'm going to do is isolate the tangent function, right, which means first adding this 1 to the other side. So I get square root of 3 times tangent of theta over 2 equals positive 1, and then divide both sides by the square root of 3. Right, so I get tangent of theta over 2 equals 1 over the square root of 3. All right, now you might say, well, why don't we rationalize that denominator? It's going to be advantageous for us to not do that yet, and I'll show you why in just a second. Right, so again, not worrying about the theta over 2 that I have inside the tangent function. Now, if I have theta divided by a number, or like a multiple of theta, like a 5 theta or a 7 theta in here, it doesn't affect how I start the problem and how I proceed, up to this point, and actually beyond this point a little bit as well. That won't come into play for a little while still. All right, so what I need to look at now is the tangent function. Where is the tangent function equal to 1 over the square root of 3? All right, so let me think about my unit circle. Those numbers, the 1 over square root of 3, that looks like a number that I'll probably find on my unit circle. So I'm not going to use a calculator here. I'm going to use the unit circle and get the exact values of my solutions. Right? Remember, if you can use the unit circle to get exact values, you want to give the exact values, right? You don't want to just put into your calculator and give decimal numbers unless you don't have a choice, right? If this was like tangent theta over 2 equals 0.473, well, 0.473 is not one of the numbers I have on the unit circle, so in that case I would have to use my calculator, right? But 1 over root 3, I'm pretty sure I can find that on the unit circle. Right, so remember, the tangent function, when I'm dealing with the terminal points on the unit circle, tangent is the y-coordinate over the x-coordinate. So my y over my x has to simplify to be 1 over square root of 3. All right, so what point on the unit circle, when I do the y over the x, will I get 1 over root 3? All right, well, if I put down my ring finger, and if you haven't seen the videos that I did on trig hand and the unit circle, you might want to check those out so you understand what I'm doing right here. But it's kind of a quick way to evaluate the points in the first quadrant of the unit circle. All right, so if I put down that ring finger, my x-coordinate would be root 3 over 2, right? And my y-coordinate would be the number of fingers below that, which is 1/2, right? So, and my ring finger corresponds to the angle pi over 6. All right, so root 3 over 2 comma 1/2. If I do the y over the x, I would have 1/2 over root 3 over 2, and the 2's are going to cancel out there, and I get 1 over root 3, and that's what I'm looking for, right? I'm looking for the tangent of my angle to equal 1 over root 3. Well, if my angle is pi over 6, when I do the y over the x, and I simplify it, I get 1 over root 3. Right, so now it's not going to be theta equals pi over 6. It's going to be theta over 2 equals pi over 6. Right, so remember, the angle that I had in here was not just theta, it was theta over 2. Right, but again, that doesn't affect anything until the next step after what I have here. All right, so I solve that equation just like I would normally. I get the tangent by itself. I look to my unit circle and I try to figure out, well, where is tangent going to give me this value? It gives it to me at pi over 6. Now, something that makes this different from some of the other equations that I've done on these other videos where I was solving equations that involve sine and cosine. Remember, sine and cosine, the period is 2 pi. Right, the period is the entire unit circle. So when I did sine and cosine, I always had to look for another point on the unit circle that gave me the same value, in this case the 1 over square root of 3. With the tangent function, I don't have to do that. Because remember, the tangent function, the period is pi, not 2 pi. Right, so the tangent function between negative pi over 2 and pi over 2, the tangent function hits every single y value that it's going to hit And then between pi over 2 and 3 pi over 2, it just repeats all those same values all over again, right? So for the tangent function, I don't have to like reflect this point over here or to another quadrant to get another solution. This is the only solution on one period of the tangent function, right? So when you're solving a tangent equation, something important to keep in mind, you're not looking at the whole unit circle. For the tangent function, you're just looking on the right half of the unit circle to find your value. And when you get your answer, the pi over 6, you put plus pi k, right? Whereas with the sine and cosine functions, you put plus 2 pi k because the period of sine and cosine is 2 pi. Well, the period of tangent is 1 pi, so I put plus 1 pi k or just pi k, right? And that's why I only have to look at half of the unit circle to get my solutions, because that right half of the unit circle, that covers the entire tangent function. The left half of the circle covers all those same values all over again, right? So I don't have to look on both sides of the circle. And there's not going to be any points in the fourth quadrant down here where if I do the y over the x, it gives me 1 over root 3. Because in the fourth quadrant, x is positive, but y is negative. So if I do y over x, it's a negative over a positive. It's never going to come out to positive 1 over root 3. Right? So I know that this point here is the only point on the unit circle, or on the right half of the unit circle, where the tangent is going to equal 1 over root 3. All right, so that's the major difference when you're dealing with sine and cosine functions as opposed to tangent. Sine and cosine, you find your point, and then you have to reflect it over to another quadrant to get the other solution on one period. Tangent, you don't have to do that because one period is only half of the circle. All right, so here's our solution. Pi over 2 equals pi over 6 plus pi k. Right, but remember, I'm solving this equation for theta, not for theta over 2. So to get the theta by itself now, I need to multiply both sides by 2. Right? If this is theta divided by 2, to cancel out that dividing by 2, I need to multiply everything by 2. Right? So I'm going to get theta equals, and then I distribute this 2 in here. Right? So 2 pi over 6 is going to equal pi over 3 if I simplify that fraction. So it's going to be pi over 3 plus 2 pi k. Right? This is going to describe all of the solutions to this equation. Right, now you might be thinking to yourself, wait a second, 2 minutes ago you just said when you're doing tangent, you only put the plus pi k, you don't need the 2 pi here, but now it's plus 2 pi k, so why is it now is a 2 pi, right? What I said is true, right? When you're solving the tangent function, since the period is 1 pi, you put just a plus 1 pi k, or just plus pi k. In this case, since it was theta over 2 and I had to multiply that 2 on the other side, that's what makes that a 2 pi k. If this was just a theta here, then our answer would be just pi k, and that would be it. But since it's theta over 2, that 2 gets multiplied over there, and that actually makes this one look like a sine or cosine function. But it's just a coincidence of this problem since it was theta over 2. If this was theta over 3, this would now be a 3 pi k on the side. All right, so this represents here all solutions to our equation. All right, that's every possible solution to this equation is going to have this form. It's going to be pi over 3 and then plus 2 pi k. So pi over 3 is going to be up here, and then adding, extra laps around the circle. That's going to solve our original equation up here. All right? All right. And if you think about it, well, never mind. I was going to say something, but I'll not even point that out, so that just might make things more confusing. All right, so that's all solutions. Now, this problem also had a part B, where it asked us to find all solutions in the interval from 0 to 4 pi. All right, so let me erase everything else I have up here, except for our solution that we found. All right, so again, this represents all the possible solutions to this equation. Now we want all solutions between 0 and 4 pi. Great. All right. Not as bad as it may appear at first. And if you watch the last video that I did where I solved the problem, I think it was a sine of 3 theta. We had to do a similar thing here. We had to give all the answers between 0 and 2 pi after we found all the possible solutions. So this is a similar thing to what we did there. All right, so, well, first off, between 0 and 4 pi, my first answer is pi over 3. All right, if I draw my unit circle here. All right, so pi over 3 is up here, right? And then, so that's going to be my first answer, because pi over 3 is definitely between 0 And then remember, all the way around the unit circle is 2 pi. All right, so pi over 3 is definitely between 0 and 2 pi. Right, to get the next one, well, it's pi over 3 plus 2 pi k. So if I add a 2 pi to this and I go one whole lap around the circle, that angle is also going to be between 0 and 4 pi. All right, so what I need to do now is I need to figure out what is pi over 3 plus 2 pi k. All right, well, think of 2 as 2 over 1, and in order to add these, I need a common denominator because this one here is a fraction, right? So to make a common denominator, I need to multiply the 1 by 3. Right, so this is going to be pi over 3 plus 6 pi k over 3. Right? Not 6 pi k. I'm just adding 2 pi. Right? I'm not adding the k here. The k here, I'm just adding the first 2 pi to it, and then I'll add another 2 pi to it. I'm kind of taking this k one at a time. Right? So I'm just adding 2 pi. So it's going to be 6 pi over 3, which 1 pi over 3 plus 6 pi over 3 is going to be 7 pi over 3. Right? And 7 pi over 3 is less than 4 pi. Right? Because 4 pi, again, think of that as being over 1. If I multiply the top and bottom by 3, that's going to be 12 pi over 3. Right? That would be equal to 4 pi because 12 over 3 equals 4. Right, so pi over 3 is between 0 and 4 pi. 7 pi over 3, right, that's still less than my 4 pi, which is 12 pi over 3. If I add another 6 pi over 3 to this, right, 7 pi over 3 plus another 6 pi over 3, right, adding another lap around the circle, well, 7 plus 6 is going to be 13 pi over 3, right, but that's going to be bigger than 4 pi. So we actually only have 2 solutions here that are in between 0 and 4 pi. They're going to be pi over 3 and then also 7 pi over 3. Right? If I add another lap around the circle, 2 laps around the circle is 4 pi. Right? So if I do pi over 3 and then 2 more laps around, that's bigger than the 4 pi. And so I've kind of gone over that limit. All right, so like I mentioned at the end of the last video, when you're doing these problems where you're solving the trig equations, especially the ones that have the multiples of the variable in here, like a theta over 2 or like a 4 theta or something like that, read the directions carefully. If it says find all solutions to the equation, pi over 3 plus 2 pi k, that's the end of it. Right? If it says find the solutions between 0 and 4 pi or 0 and 2 pi or 0 and 1 pi or whatever it is, you have to then do things like this to figure out, well, which solutions are going to fall in that range that they're giving me. Right? So you just start with your initial one, the pi over 3 in this case, and then you just add 2 pi to it over and over again until you go over that limit that they set for you, the end of that range that they asked for the answers, right? So in this case, the end of the range was 4 pi. So I just have these 2 answers. The next answer, when I add another 2 pi to that, takes me past the end of that range, and so I don't include that answer on the list. All right, so that's solving trigonometric equations. These are, the last couple of videos that I did, those last couple of examples, are fairly complicated types of problems, especially when they start asking you to list a certain, certain responses within a certain range. But if you just take your time and think about what they're asking you, and this little formula here is giving you the answers, you just have to do the pi over 3 plus 2 pi, and just do that over and over again until you get all your answers.